So I've recently, just a few months ago, I attended a 1 month field course with the Tropical Biology Association, and the 2024 chapter was held in Kibale National Park in Uganda. Now, Kibale National Park and Uganda in general is known to be the primates capital of the world, with over 120 species of mammals, and well, some of the primates they have over there include the red-tailed colobus. Other species include some very unique and diverse group of bird species. I think over 300 species, and one of them is the red-headed broadbill, sorry. And we had caught this bird during mist netting exercise. And this is another one of the primates, the olive baboon, that was trying to sneak into a room next to mine while we were there back at the camp. And this is another one, the black and white colobus. This picture is that of the blue-headed tree agama. One of my friends that worked on this for the project, and it's a very interesting species. And one of the most interesting parts of the course, I would say, is the fact that I got to learn alongside a very diverse group of people with an equally diverse sort of experience. So it was really lovely learning with and from these people. And this person over here is the person I ended up working on my project with. His name is Miaro. He's this wonderful researcher from Madagascar, and he had gone to the bathroom one day and saw the black and white colobus, and shall I say bravely decided to take a picture with it, which I'm sure I would not have dared to. And these are also other pictures of a butterfly and a non-insect we had gotten during a trapping exercise. Well, unknown to me, I could never really come around to identifying it. And then we'd gone on a safari to Lake Mbururu, and this is a zebra we'd seen there. And this is a picture of the, oh, I don't know what's going on, but the last picture over there is that of the black and white cast hornbill. First of all, an ornithologist, and I have a deep love for birds, and that is one bird I really fell in love with while I was at Kibale National Park. So we were expected at the end of the field course to come up with a project of our choosing. And what to me and my partner, what we found to be the most interesting about where we were was the tropical rainforest. Now, the tropics is mostly known for its distinct level of stratification. So we have the canopy level and the understory. So we were really interested in this stratification, and what we were so interested about was how at these different levels of stratification, we have different levels of temperature, different levels of light, as well as different levels of wind velocity, and all of these factors combined creates very unique niches which different organisms tend to utilize for foraging purposes, for mating purposes, for their nesting, roosting, and so many other behaviors like that. So we were interested in looking at what kind of variation was going on at different levels of the canopy. But then what we had realized during our literature review was that very few work has been done. While a lot of work has been done comparing stratification, that is by the canopy level and the understory, it found that very little, if no work at all, has focused on looking at what was going on within the understory to see if there was any sort of variation and different levels of stratification as well within the understory. So that was something we were interested in. And well, as I said, my project partner and I we had done this other projects during one of the field exercises on birds pollination, because we were both interested, we still are interested in pollination, but and birds as well. So when it was time for us to come up with a project topic, we said, oh, would use birds as our focal species. But then we'd realized that as much as we spent a lot of time trying to learn all the bird calls and everything in Kibale National Park, we knew deep down that we could not do any bird survey justice in the short period of time we had for the research. So we thought, well, what other species, what other taxon can we use to answer our research questions? And we thought, well, we could look at butterflies really, because they're some of the most well-studied and widely distributed insect species. And then we knew that we could identify them. They were easily identifiable by our standards. We had field guides, we could trap them and be able to identify them. We said, okay, yes, butterflies make a lot of sense for us to study. And not only that, but because they are also widely distributed and good bioindicators, they give a good representation of what is going on in their environments. We said it would make a lot of sense to use that, and we'll see that we've been able to pick a taxon that is quite representative, that will give us a good representation of what is found in the ecosystem. So we'd come up with the project topic, assessing the vertical distribution and dietary preference of butterflies in Kibale National Park, Uganda. And this was supervised by Professor Irene Tellman. So we had our main question, and we had three research questions. We came up with research questions to enable us answer the broad questions. And the first was how the abundance of small and large butterflies were stratified in the understory along forest tracks in Kibale National Park. And the second research question was to find out how butterfly community composition differs between the lower and the upper stratum in the understory. And the third and final research question we come up with was to find out how bait type affects the butterfly community composition captured in the lower and upper stratum in the understory along forest tracks in Kibale National Park. And this picture over here is that of the Euphedra medon, one of the butterfly species that was widely distributed and which we had come across a lot of times, and we both really liked. So that's why it's up there. So to answer our first objective, what we did was set out an 80 by 4 meter long transect, so 80 meters long and then 4 meters into the forest. And we had a total of 4 of each of these transects per day, and we had walked those transects for a total of 10 minutes. And what we did was categorize our lower stratum as anything from 0 centimeters, that's ground level, to 130 centimeters. And then our upper stratum as anything from 175 centimeters to 305 centimeters. So the window in between 130 centimeters to 175 centimeters, we tried as much as possible not to survey, to avoid any sort of pseudo replication. So from butterflies that are coming down, or butterfly species from the lower stratum that were moving up. And we had also categorized large butterflies as butterflies that are greater than 40 millimeters, and then small butterflies as butterfly species that are less than or equal to 40 millimeters. And we each had 2 counters for the 2 different stratum, that is the lower and the upper, and then for the 2 different sizes, both small and large. So each person had one for the stratum person was recording, to ensure that we had the most accurate collection of data during this process. And what we found at the end of 4 days worth of data collection for this very objective was a total of 520 butterflies recorded along a total of 16 transects. So we had collected transect data for 4 different transects per day. And because we've done that for 4 days, 4 times 4, we had a total of 16 transects. And to analyze this data, we had used a generalized linear mixed effect model on R to answer the question, which and what we had was stratum. What we had was what we did was check the interaction between size of the butterflies and stratum, so to see if the abundance of butterflies by size was dependent on the stratum at which it was found. And we found that yes, there was a statistically significant effect of stratum of size, of size depending on the stratum it was found. So we had found that on the lower stratum, it had the highest number of butterflies, and those butterflies were specifically small butterflies. So a total of 223 individuals were found on the lower stratum. But then on the upper stratum, we had the least number of individuals, and they were all large butterflies, so a total of 90 of them. And I think I did not mention this, but what we had was transects as a random term to account for any variation that might have occurred whilst collecting data along the transects. And what we did was take things a step further by adding temperature data we had collected into the model to find out what would happen if what the relationship was between temperature and butterfly abundance. And we had found that with increase in temperature, there was an increase in butterfly abundance. So temperature was a statistically significant predictor of butterfly abundance. And we had interpreted this to be that abiotic factors such as temperature and light by extension temperature, and stratum were significant regulators of butterfly behavior. So with an increase in light, butterflies were more likely, with an increase in temperature rather, because butterflies are poikilothermic, they are more likely to carry out their life cycle processes such as foraging and mating. And how stratum affects butterfly distribution by size, we'd interpreted this to be that it could be as a result of some sort of defense mechanisms. So as some sort of evolutionary defense against predation, in the sense that large butterflies are more likely to be seen and picked on the ground by predators than they are to be if they're slightly higher in the canopy. While what we also interpreted this to be is that it could be some sort of evolutionary mechanism for thermoregulation, because they need the temperature, an increase in temperature for their flight and so many body processes. The higher up the larger butterflies tend to utilize more temperature for their processes, such as flight. So that is what we've interpreted this to be. And to answer our second objective, what we had done was use fruit baits, and the fruit bait used specifically was rotten bananas. So it was a mixture of rotten bananas with some alcohol, and we were sure to be consistent with the brand of alcohol we were using for the whole of the 4 days, as well as some urine, and we were also consistent with the urine we had used for it. And we had used the corn type bait trap. We had a total of 12 of those. And what we did was set them up at the upper and the lower stratum, but in this case, our lower stratum was not ground level to avoid any interference or interaction with our baits by insects visiting it or any kind of other species unwanted, in this case, having an interaction with our bait. So we set it up at 0.2 meters, so slightly above the ground, and our upper stratum here was 3 meters. And how we had put these traps up was using some sort of pulley system where we would throw a rope up and then pull the trap to that level. So we would set our baits. And earlier I said we had a total of 12 of these traps, but because we are setting them up 2 per side, we ended up with a total of 6 pairs. And what we did was alternate the placement of the baits. So they were 20 meters apart at alternating angles of the forest tracks. So this was to enable us get a more accurate representation of what was going on at different parts of the forest tracks. And so we'd set these traps up by 10 a.m. and we checked them 3 times in a day. So by 12 p.m., by 2 p.m., as well as by 4 p.m. So what we did at each of this period was to take down the traps, take a picture of each of the butterflies we had gotten in our traps at that time, replace the baits, and then put them back up. And we had later identified those species using the butterflies of Uganda Kibale Forest field guide. We had also collected this data for 4 days. So at the end of the 4 days, we found that we had a clear distinction in the number of species we had found at the different stratum, with the lower stratum having 42 species, double what we had found in the upper stratum, which was 21 species as compared to the 42 that was found down. And we also found, we wanted to see if there was any sort of distinction between the kinds of species that were found per site and what those species were. And what we found was that the lower stratum had a total of 26 species that were unique to it. And some of those 26 species includes the Euphedra uganda, the Euphedra perusi, as well as the Aterica galen, while we had found that the upper and the lower stratum had 17 species that were unique to both the sites. And we checked what was found to be unique to the upper stratum, if any species were, and we found that 5 species were unique to that stratum. And we wanted to find out more about the population dynamics. Yes, the numbers, there's a clear distinction in the numbers, but we wanted to find out how balanced or in equilibrium the population was. And what we found was that the lower stratum, as much as it had a higher level of diversity as compared to the upper stratum, it was actually not in equilibrium. While the upper stratum, as much as it had just 5 species unique to it as compared to the 26 species that were found down, it was in a much more stable state as compared to the lower strata. And we had interpreted this to be a case of niche differentiation and resource partitioning, that this species must have evolved to be able to utilize these different niches as well as the different resources that are found there. And we had also interpreted this to be a case of generalists and specialists, where in the lower stratum we found certain dominant generalist species like the Bicyclus bea completely dominating the stratum, while in the upper stratum we had more specialists and they were fewer in number. So in contrast, the absence of the dominant generalists in the upper canopy allowed the specialized feeders to exist in a state of more stable equilibrium as compared to the lower stratum. So because we had found differences in the butterflies per stratum, as well as per food resource, we wanted to introduce a different breed type and see what would happen if we had done that. And what we did was use fresh banana breeds. So earlier I mentioned we'd used a fermented banana mixture, but then this time around we wanted to use something fresh to give us as close a representation as what can be found in the wild. And we had fresh bananas. So for the other bait, we had wanted to use baboon dung because during the pilot studies we had used that and we found that the butterflies were quite responsive to it. So we wanted to find out what the community composition would be like if we had actually used that. But then when it was time for us to collect the baboon dung, we could not find any olive baboon droppings around, which was crazy because they were everywhere in the camp, but somehow there were no droppings. And we thought, well, what could we use as a substitute for the dung, for the baboon dung? And we thought, well, we could use cow dung because it is it has a similar texture to the baboon dung. But then again, we also rationalized that using the cow dung would be introducing a completely foreign entity, which is quite contrary to what we had wanted to do, because Kibale National Park it's a protected area that does not have any issues with cattle going in. It will not be a good representation of what was found there. So we opted to use elephant dung, and we're lucky enough that after scouting through the forest and everything, we're able to get some, which is what we did. And we had a similar setup as the previous objective. just that we had swapped out the kinds of beads that were used. We had still snapped the pictures and identified them afterwards. And what we found was a total of 117 individuals of butterflies distributed across 33 species. Now, for the other two objectives, we had collected data in a period of 4 days, but by this time we were running out of time. We actually had to take a day out of our writing time to do this because it was something we were really, really interested in. And what we found was that we had more fruit feeders in general as compared to the dung feeders. So at both stratum, that's the lower and upper stratum, the fruit feeders were more dominant as compared to the dung feeders. And well, this picture over here is our beats at a slightly upper level, though we're tilted it a bit. And well, the picture rather is tilted, yeah. And what we had interpreted the difference in butterfly community composition based on bait type was that it could be as a result of the speciation of the purposes to maximize access to the resources. So it has resulted in some sort of specialized feeding. And well, so many previous studies have shown that butterflies have a highly specialized feeding preference, where we have some species to be completely fruit specialists, nectar specialists. Another study had actually shown that there's a group of butterflies that are dog dung specialists. So it could explain why we had a difference in butterfly composition when we switched out the bee type. And the thing about the proposis is that the different dung we'd used had different texture, where the banana had a much more smoother texture as compared to the elephant dung, which is quite coarse and stiff. Is that the right word? So it could explain why we would have butterflies with different purposes utilizing those resources. So what we found at the end of this, at the end of the period of data collection and analysis, was that abiotic and biotic factors, abiotic being the stratum as well as temperature, were significant predictors of butterfly abundance. So butterfly abundance was found to be dependent on temperature as well as the stratum it was found. And as for the biotic factors, the food resources, so in our case, the elephant dung, the fresh banana, and the rotten banana mixtures were significant predictors of butterfly abundance, because we have found that there was a change in community composition with a change in bee type. And we had interpreted this conservation we had interpreted the conservation implication of this study to be that there is enough variation within the understory, and there's need for a constant monitoring effort to be set up for the butterflies in Kibale National Park, because as I had mentioned earlier, very little work has been done in butterflies in Kibale National Park, especially looking at the different stratum. Actually, the only research that's been done was a population inventory from, I think, over 10 years ago. So there's need to continue doing that to find out what is going on. And in the face of increasing temperature due to global warming, by extension, climate change, we would like to know what would happen to the butterfly communities, not just in Kibale National Park, but in so many different places, as their life cycle processes are quite dependent on temperature. So not just butterflies or every other species, but because butterflies are what we worked on, we are a whole lot more interested in it for the purpose of this research. And future projects, we believe, should compare between the understory and deep into the forest. So during one of our forest walks, we had seen some butterfly species deep in the forest that we had never seen while collecting data along the forest tracks. So it would be nice to have a similar setup and see what would happen if we compare between the two different parts of the forest. And one unique thing about Kibale National Park is that the tropical rainforest has both a locked section and an unlocked section. So it would be nice to also compare between those different sites and see if would have a similar results or if it would differ in any way. And the limitations of the study would say would be time, first of all, because well, as I mentioned, we had collected the data for the first objectives for just 4 days and the second one for 2 days. So it would be really nice to look at this for a longer period of time and see if the variation would even out or if we would actually end up seeing more variations. I think that is all. So I am so thankful to these people. First on the list is my project partner, Miaro, our supervisor, Professor Irene Tillman, Dr. Rosie, who is the director of the TBA, and all these other amazing people on the list. Thank you. I'm so grateful to all of them. And thank you for listening. That is